Hi, it's Adam here. Welcome to the part 3 of our talk about self-hosted CI/CD agents on Azure Kubernetes Service. In this episode, we will talk about GitHub Actions. The process will look as follows. We will push the changes to GitHub Actions. GitHub Actions will send the job to the Kubernetes service. On the Kubernetes service, we will have the running agent of the GitHub Actions, and we will run the job on that agent. We'll build and push the image to the container registry, and then we will upload or pull that image and deploy our demo application. This is part 3 of our talk about that topic. I encourage you to check part 1 and part 2. I will link this blog in the description of that movie so we can check it. I also encourage you to read the documentation about that topic to get more insight about GitHub Actions. So, what are the difference between GitHub-hosted and self-hosted runners? You will receive all the updates to the operating system and the tools. It's managed by GitHub, so it's on their site. They provide clean instance every time you execute a new job, and use 3 minutes of the GitHub action plan. But for the simple project, you can run it for free. On the opposite, we have the self-hosted runners, where we have to update the self-hosted application, but we will receive the automatic updates for the runner from the GitHub, but for the system and other tools we have to take care of it. We will have to pay for the machine, but if we already have the system there, so we already have to pay for the machine when we will run the jobs. We can customize the operating system, software, tools. We can have more secure setup for our needs. We don't have to clean the instance every time and the new job is running. So and it's free to run the self-hosted runner in the GitHub. Let's see what we'll do. We'll create the AKS cluster with workflow identity and couplet identity. We'll create Azure Container Registry. We'll assign roles for the kubelet identity and workload identity. We'll create Kubernetes objects for workload identity and for GitHub runner. In the second part of this video, we'll also test how to set up this runner with Actions runner controller. Here's the link. Here is also the link to all the files that I will use in that film, so you can check it. First, let's create the cluster and container registry. In the link in the GitHub repository, I provided the script which will simplify the provision of that cluster and container registry. Here is how it looks like. We'll export our names for our convenience. We'll create the resource group for our resources. Here we'll create manage identity for the cluster, manage identity for the kubelet. We'll create our group ID. We'll add our user to that group. Also, we'll create the container registry. And then we'll provision the cluster where we'll provide assigned our identity for the kubelet, and also we will enable workload identity. And at the end, we will get the ID of our cluster. For this film, we will use the smallest available virtual machine for our cluster. Okay, so let's go back and let's start to provision it. After our cluster is provisioned, it's time to get the credentials and check if it's running properly. So we'll get the credentials and we will check if the nodes are properly running. As we can see, our cluster is running. Right now, let's create the workload identity. We'll also get the client ID and principal ID of that workload. We will need it to later to assign roles to that identity. Now let's create Kubernetes service account in GitHub namespace. So here we'll create the namespace, and here we'll create the service account for our workload identity. We need to fill the workload client ID. So let's check it. Okay, we have the ID. And now I will do it in the code editor, so it will be easier for us. After I will correct the file, let's run and apply the changes. Okay, it's created. Next, let's create a cluster role and cluster role binding for our service account. We need this, so our account will have the rights and roles to the whole cluster. We will need it to provision our pods, not only in our own namespace, GitHub namespace, but also in other namespaces. For that, we also need to get the workload principal ID. And if you follow along with me, you will have to edit that file, which you will get from the GitHub repository. So let's get the principal ID and run the commands. Role and role binding is created. Right now, let's create the federated identity credentials for our workload identity. After that, let's create the custom role for our workload identity, so we can pull, push, and also list resources in our container registry. In that file, you need to provide your subscription ID. Once you update the file, we can create the new role in our subscription. The role is created, and right now we can assign that role to our workload identity. After a few seconds, we are able to assign that role. Next, we will need to assign Azure Kubernetes Service cluster user and service RBAC writer to our workload identity. So we will be able to get the credentials in our pipeline and also provision our application. Let's do it right now. Okay, everything should be set up and right now we can start the installation of GitHub Actions self-hosted runner. Let's go to our repository. Let's go to settings. Let's go to actions and runner. Here we'll click new self-hosted runner. We'll choose Linux. And here you can see the instructions. But we will simplify that step since I already prepared the Docker file that will install our runner. So let's go back here. We'll install Azure CLI, and we will install also our action runner. The image is not perfect, it wait a bit, but for our convenience we will do it like that. And we will build and push it to our already created container registry. It may take a moment, so I will start the command and we'll meet shortly. We managed to push our image to our repository. Next, we'll create a storage class and persistent value claim. The storage class will have mounting options set to these values since we created our image and the user with these values. And here's the persistent value claim. We can create that objects. And next, I choose to create the stateful set for our service, for our runner. You can also use deployment. It depends what you need. This is what I choose for that presentation. Here is the service name. We add our label for the workload identity. Here also, here we added our service account. Here we will provide our custom image. I will have to change that name since we just created the container registry with different names. So we need to update this. And after that, we will apply. Let's check name of our registry. And update the file. After we update the file, let's create the stateful set. It may take a moment to provision and to start the pod. So let's check if our pod is running. Our custom image, as I mentioned, is not perfect, so it may take a few moments. Usually we can install all the dependencies in the pipeline and to make our image small enough so that it will be faster to pull it from the registry. As you can see, our pod is running. So right now we can start to configure our runner. Let's go inside the container. And right now we need to run the following script with the token. Let's go back to GitHub. Here you'll be able to get the token. Please keep in mind that it's only valid for 1 hour. So sometimes if you do the steps and it takes you more than 1 hour, this token will expire. Let's go back and let's run the script. You can see that we managed to connect to the GitHub Actions. We are authenticated. Here you can choose the name, but we already set that name in our stateful set. So it will have this name. Here you can add the labels and then you can run the pipeline and provide label for your runner. So the pipeline will run on the runner that you choose, not on all the runners. Runner is successful added. And as for the workload and work folder, we'll also use the default settings. So everything is set up. Here is the presentation, and we can start the runner. Okay, it's connected. Let's go back to GitHub. And here you can see the runner. Here are the labels and the status of that runner. Great. Here's our example workflow for that runner. We'll check out the branch. We'll log in with workload identity. We'll provide the server principals, tenant ID, and the federated token. These values are already mounted in the pod. Then we'll build the image, right? And then we'll log into and get AKS credentials. Use the new kube login to convert the kube config. And then we will deploy the application. Right now I'll have to update the name of our container registry, and then we will push changes to the repository, and we will see how all will work. So let's see in a moment. Here we updated the name of the container registry. Let's start the commit. Let's go to Actions. And let's see, we see that the job is already started. Let's go to our application. We see that we managed to log in. Right now we are building our image. Right now we're getting the credentials for our AKS cluster, and now we deploy the application. And the pipeline finished. Here we can also see that the job was successful. Let's check if the image is in the repository. Here you can see that our GitHub demo was just pushed. Let's open the new tab and let's see if our application is running. Great, here you can see that we managed to provision the GitHub demo application. In this part of our video, we'll set up our self-hosted runner using Action Runner Controller. Here is the link to the documentation. I will also link it in the description of that movie. This controller will simplify the installation of our runners. We can also make the runners ephemeral, so they will be deleted after the successful run of our pipeline. We can also add the high availability scaling to it, so this tool looks very promising. So I encourage you to test it. Before we will start the installation, let's clean up our environment. So you should delete the runner which we created beforehand. Let's delete our demo application and also delete the stateful set. So if you check if we have any pods in the GitHub namespace, it will be empty namespace. First, let's install Cert Manager, since this controller requires this manager. Now you need to obtain the personal access token. We will deploy this controller using Helm. So let's add the repository. And now we will install it in Actions Runner System namespace. And here we will have to provide the token to our GitHub repository. After our installation is successful, we will be able to see the controller in the Actions runner system namespace. Next, we will create our deployment. This is the special object for this controller. We can specify our names. We'll also add our service account. We'll make that this pod will be ephemeral. We added our custom label, and it will appear in the GitHub runner. So we'll be able to run the pipeline with this label. We do not have to make any customizations here, rather than you need to provide your repository name. Let's create that object. You can see that the object is created. Let's check that it's running. We can see that our runner is in the pending state. Let's check in a moment if it will start to run. Okay, you can see that the runner is in the running state. Let's check the pods. Okay, yes, you can see we have one pod already. Let's go back to the repository. Here, as before, we will make the changes to provide our current container registry name. In this pipeline, we had to make small changes. I added script to install Azure CLI and kubectl. As you remember, before we created our custom image, but in this case, the image is used from the controller. So we will install our dependencies in pipeline. Then we will install kubelogin, and we will log in with workload identity the same as before. We'll build and push the image to the container registry. We'll get the credentials for our cluster, and then we will log in with workload identity and deploy the application. So let's commit the changes. Let's go back to settings and runners. Here you can see the name of our runner here with the special label, and it's active. Let's go back to actions. And here you can see all the steps. Okay, it took 1 minute and 25 seconds to complete that pipeline. Let's check if our demo application is running. Here you can see that we managed to provision the application. We managed to provision our application using GitHub self-hosted runners, which we installed by ourselves. And in the second part, we used Action Runner controller to do the same. This controller has much more options, as I mentioned, that we can scale our pods right away, and we can provision them using our personal access token, so it will provision it automatically. You can also write your own script to do it the same, but that tool is promising, so you can check it out. Thank you for your attention. I hope you like it, and see you in the next video. Also, I encourage you to check my previous video about that topic, and in part 4 we will focus on Azure DevOps and self-hosted runners there. Thank you, and see you in the next video. Bye.